What truly powers our world? When you look out over a city at night with its endless lights and humming energy, it's easy to think of electricity, oil, or even the sun as the main drivers of our civilization. But if you dig a little deeper, you'll find something even more fundamental at work. Beyond the familiar solar panels and power lines, there's an element at the very heart of matter that has quietly, yet dramatically changed the course of human history: uranium. This isn't just another mineral, it's a force of nature, hidden in plain sight, waiting to be discovered. Uranium stands out as one of the heaviest naturally occurring elements on Earth, a true heavyweight of the periodic table. Its atomic mass is so great that it sits near the bottom, a giant among its peers, and its presence has shaped the world in ways few could have imagined. But uranium isn't just a rock you find buried in the ground, it's a key that unlocked a new era in human history. Its most important secret? Instability. Unlike most elements, uranium is always on the edge, teetering between order and chaos. The uranium nucleus is so densely packed with protons and neutrons that it's like a Jenga tower stacked to its limit, always threatening to collapse. This delicate balance makes uranium both fascinating and dangerous. This inherent instability leads to radioactivity. Uranium naturally decays, releasing powerful bursts of energy in the form of radiation. These invisible forces can be harnessed, but they also demand respect. Thanks to this property, we've learned to generate vast amounts of electricity, lighting up entire cities and even peer inside the human body with X-rays and medical scans. Uranium's energy has become a cornerstone of modern technology and medicine. For centuries, uranium was just a mysterious heavy mineral called pitchblende. Miners and scientists puzzled over its strange properties, never suspecting the world-changing power it contained. Nobody realized that this unremarkable black rock could one day light up entire cities and revolutionize science forever. It was a hidden treasure, waiting for the right moment and the right minds to unlock its secrets. The story of uranium is a tale of curiosity, accidental discoveries, and the relentless pursuit of knowledge by brilliant minds. It's a journey that spans centuries, filled with moments of awe and breakthrough. What began as a mining nuisance, just another heavy rock in the earth, became one of the most significant scientific discoveries of all time, reshaping our understanding of energy, matter, and the universe itself. It's a reminder that even the most ordinary things can hold extraordinary secrets, waiting to be revealed by those who dare to look closer. So let's travel back in time and uncover how uranium went from a forgotten mineral in the earth to a world-changing element that continues to shape our lives today. Get ready. This journey through the story of uranium will blow your mind and change the way you see the world. Our story starts deep underground in a world of darkness and echoing footsteps, where the only light comes from flickering lanterns held by determined miners. These tunnels, carved beneath the earth, are filled with secrets and stories waiting to be uncovered. In the heart of the Bohemian countryside, in what's now the Czech Republic, silver mines drew fortune seekers from across Europe. The promise of wealth lured generations to these rugged hills, shaping entire towns and communities. But as miners chipped away at the rock, searching for gleaming veins of silver, they kept stumbling upon something unexpected, a dense black mineral known as pitchblende. This mysterious substance was heavy, almost unnaturally so, and its tar-like appearance set it apart from the precious metals they sought. To the miners, it was nothing but a stubborn nuisance. Unlike silver or lead, pitchblende didn't shine or melt in familiar ways. It resisted every attempt to fit it into the known world of valuable ores, leaving miners puzzled and frustrated. For years, perhaps even centuries, pitchblende was tossed aside, heaped in forgotten piles outside the mines. Its secrets remained locked away, ignored by all but the most curious. Early chemists, intrigued by its stubborn nature, tried every method they knew to unlock its mystery. They crushed it, burned it, dissolved it, but pitchblende defied all their efforts, keeping its true identity hidden. Among the miners, stories grew. They whispered that the black rock brought only bad luck, calling it pitchblende, combining the words for pitch and misfortune. Some even believed it cursed their work. Superstition filled the gaps where science had no answers. In the dim light of the mining quarters, tales of pitchblende's ill fortune spread, adding to its mystery. But as the Age of Enlightenment dawned, a new breed of thinkers emerged. Where miners saw only trouble, these scientists saw a tantalizing challenge, an unsolved puzzle waiting for a breakthrough. The quest to identify all the elements of nature was underway, And pitchblende, once ignored, was about to get a second look from the world's most curious minds. Armed with new techniques, better instruments, and an insatiable curiosity, chemists prepared to probe deeper than ever before. They believed every rock had a story, and pitchblendes was waiting to be told. That black rock, ignored and misunderstood for generations, was finally about to reveal its true nature, a secret that would change science forever. All it needed was the right mind to ask the right question, and the patience to listen to what the stone had to say. Enter Martin Heinrich Klaproth, a meticulous German chemist whose curiosity and attention to detail set him apart from his peers. In an era when the secrets of the natural world were just beginning to be unlocked, Klaproth was determined to push the boundaries of what was known. In 1789, Klaproth acquired a mysterious mineral called pitchblende, a heavy dark rock that had puzzled scientists for years. Driven by a desire to uncover its secrets, he set out to analyze it with the tools and knowledge available at the time. He carefully ground the pitchblende, dissolved it in acid, and painstakingly separated its components, expecting to find only familiar elements like lead or iron. But Klaproth was about to stumble upon something entirely unexpected. Instead of the usual results, he discovered a strange yellow compound that caught his eye, a color and texture unlike anything he had seen before in his experiments. When he heated this yellow substance with charcoal, it transformed into a dense black powder. This new material was heavy and mysterious, and Klaproth realized it was something the scientific world had never encountered. In that moment, Klaproth understood he had discovered a new element, one that would eventually change the course of history. Inspired by the recent discovery of the planet Uranus, he decided to name his new element uranium, linking his breakthrough to the wonders of the universe. Although Klaproth had actually isolated uranium dioxide rather than pure uranium metal, his achievement was still groundbreaking. He had revealed the existence of a new element, opening the door to future discoveries. Isolating pure uranium would take scientists many more decades, but Klaproth's work put uranium on the scientific map and sparked curiosity around the world. He saw potential in pitchblende that others had missed, recognizing that this unassuming mineral held secrets far beyond what anyone imagined, even if he couldn't yet grasp its true power. This was just the beginning of uranium's incredible journey, from a scientific curiosity to a substance that would shape the destiny of nations and the future of technology. Sometimes all it takes is one person with vision and determination to see what others overlook, to notice the extraordinary hidden within the ordinary. Klaproth's discovery was only the first step in a much larger story, one filled with promise, danger, and world-changing consequences. The true secret of uranium, its immense energy and potential, was still waiting in the shadows, ready to be revealed to the world. From that moment on, the world would never be the same. Uranium's story was destined to touch every corner of the globe, for better or for worse. The next chapter in the saga of uranium was about to begin, and its impact would echo through history. For a century after Klaproth, uranium was mostly a curiosity, used to color glass. That changed in 1896 with Henri Becquerel, a French physicist fascinated by X-rays and fluorescence. He wondered if uranium salts, when exposed to sunlight, might emit X-rays. Becquerel placed uranium salts on a photographic plate wrapped in black paper, expecting sunlight to trigger something. But cloudy weather delayed his experiment, so he stored the setup in a drawer. On a whim, he developed the plate anyway, and found a strong image, even without sunlight. The uranium salts had emitted powerful, invisible rays on their own. Sunlight had nothing to do with it. Becquerel had stumbled onto a new phenomenon. Uranium was spontaneously radiating energy. He had discovered radioactivity. This accidental finding would turn the world of physics upside down. Sometimes the biggest breakthroughs come from unexpected places. The age of radioactivity had begun. Becquerel's discovery intrigued a young scientist in Paris, Marie Curie. Using a sensitive electrometer, she measured the mysterious rays from uranium and found that thorium did the same. She coined the term radioactivity, but when she tested pitchblende, she found it was far more radioactive than pure uranium. Marie hypothesized another, even more radioactive element was hidden in the ore. With her husband Pierre, she began the painstaking process of isolating it. Working in harsh conditions, they processed tons of pitchblende, searching for the source. In 1898, they discovered not one but two new elements, polonium and radium. Radium, intensely radioactive, confirmed Marie's bold theory. The Curie's work revealed the hidden power inside pitchblende. Their discoveries would change science and medicine forever. The world was now aware of radioactivity's true potential. The discoveries of Becquerel and the Curies shattered the old idea of the indivisible atom. Radioactivity showed that atoms could change, transforming into other elements and releasing vast energy. This opened the door to nuclear physics, a new field exploring the atom's core. Scientists realized the energy came from the nucleus, not chemical reactions. This led to breakthroughs like radiometric dating, revealing Earth's true age. The atom was no longer a simple building block but a source of immense power. The quest to understand radioactivity inspired a golden age of discovery. The world would never look at matter the same way again. Uranium's journey accelerated with the discovery of nuclear fission in 1938. Scientists found that splitting a uranium-235 nucleus released enormous energy and more neutrons, triggering a chain reaction. Controlled, this reaction generates heat to produce electricity in nuclear power plants. Today, nuclear energy provides a significant share of the world's carbon-free power. Radioactive elements also revolutionized medicine. Nuclear medicine uses tiny amounts of radioisotopes to diagnose and treat diseases like targeting cancer cells with radiation. These advances trace back to the curiosity of early scientists. Harnessing the atom's power has transformed how we live, heal, and generate energy. Fundamental research led to practical breakthroughs beyond anyone's imagination. The nucleus became a source of hope and challenge for humanity. Uranium's story is one of both promise and peril. The same fission that powers cities can also destroy them. This is the principle behind the atomic bomb. Nuclear weapons showed the terrifying potential of atomic energy, yet nuclear power offers clean, reliable electricity, helping fight climate change. But it also brings risks: nuclear proliferation, accidents like Chernobyl, and the challenge of managing radioactive waste. The responsibility to use this power wisely is immense. Science gives us tools, but not the wisdom to use them. The atom's power demands international cooperation and careful regulation. With great knowledge comes great responsibility. Our future depends on how we wield the power of uranium. What can we learn from uranium's journey? The power of curiosity. The story wasn't planned, it unfolded through questions, accidents, and perseverance. Claproth, Becquerel, and the Curies weren't seeking world-changing discoveries, they were driven by wonder. Science moves forward through unexpected turns and open minds. Sometimes the biggest breakthroughs come from results no one expected. The Curie's dedication shows that discovery requires hard work and resilience. The story of uranium is a call to stay curious and keep asking questions. The next big discovery could be hidden in something ordinary. The quest for knowledge never ends. Every one of us can be part of it. So go out, explore, and maybe you'll change the world.